An AC circuit is composed of serial connection of a resistor with resistance 50 ohm and a coil with inductance 0.3 Henry and the capacitor with the capacitance 15 microfarad. And the circuit is connected to the AC voltage source with the amplitude 25 volt and the frequency 50 Hz. Now determine the amplitude of electric current in the circuit and the phase difference between voltage and the current. And draw the phasor diagram of voltages and current in the circuit. Now let's see how to solve this problem. First write the given data and secondly analyze the tasks to be accomplished and then draw the phasor diagram. Next we will derive the formula for total impedance from the phasor diagram and then we will evaluate the amplitude of electric current. Next up we will evaluate the phase difference from the phasor diagram. After that the numerical substitution in the formula and finally calculate the result and draw the circuit diagram. First write down the quantities. The resistance of resistor is 50 ohm. The inductance of coil is 0.3 Henry. And the capacitance is 50 microfarad. And the amplitude of AC voltage source is 25 volt. And frequency of source is 50 Hz. And here the resistor, coil and capacitor are connected in series. So from the given values we need to determine the amplitude of the current in a circuit and nextly the phase difference between voltage and the current in the circuit. Now let's see how to solve this task. First we will evaluate the current amplitude. For that we apply the Ohm's law for alternating current which expresses the relationship between an overall impedance Z, voltage amplitude of the source Um and current amplitude Im. To calculate these values we know the quantities from the given data. Here the electric current flowing through all the components are connected in series of same size. But the voltage on the components is out of phase with the current. Next, to obtain the phase difference between the voltage and current, we use the phasor diagram. Now let's see how to draw phasor diagram. A phasor is an arrow that we use to plot the current and voltage value on the individual components of the circuit into a phasor diagram. Its magnitude reflects the amplitude of the voltage or current and its direction indicates a phase angle. Now let's see how to draw a phasor diagram for a series circuit. First we plot the values of voltage and current on the individual components in the AC circuit into a phasor diagram. Here the current is same size on all the components. So the phasor of current Im is therefore same for all components and is usually drawn in positive direction of x-axis. And next the phasor of voltage is on the resistor UR is parallel to the current phasor because the phase difference between voltage and current is 0. In this case voltage and current are in phase. In this figure the phasor is illustrated by green. Next the voltage on coil UL leads the current by pi by 2. That is quarter of the period. Therefore we draw its phasor pointing upwards. That is in the positive direction of imaginary y-axis. Here we consider the fact that the phasor rotates in the counterclockwise direction. In this figure the phasor is represented by yellow. Next the current on the capacitor leads the voltage UC by pi by 2. So we draw the phasor pointing downwards. That is in the negative direction of y-axis. And this phasor is represented by pink. The amplitude of overall voltage is obtained by vector sum of phasors of voltage on individual components. First we subtract the voltage on the capacitor UC from the voltage on the coil UL. In the picture it is drawn in purple. Then we add this vector and the vector of the voltage on the resistor UR. The phasor of the voltage amplitude of the entire circuit is represented by light blue. A phase difference between the voltage and the current is said to be the angle between the current phasor and the overall voltage phasor. Here the angle is phi and is drawn by navy blue. So for the RLC circuit and the given quantities, the phasor diagram will look like this. And note that in following figures the phasor diagram are not illustrated by the same colors. Next we will derive a formula for total impedance Z from the phasor diagram. To get the total impedance Z from the phasor diagram, instead of using the voltage on the individual components in the phasor diagram, we plot the inductance XL and the capacitance XC and the resistance R. So from Ohm's law we know that UC equals Im into XC, UL equals Im into XL and UR equals Im into R. Since the current through all the components is same, the impedances of individual elements are proportional to the voltage. So we can draw the diagram similar to the voltage phases. Now to calculate the impedance Z, we use the rectangular triangle as you can see in the phasor diagram. And the impedance Z is evaluated using Pythagoras theorem. The difference between the relationship is whether the current leads the voltage or the voltage leads the current. And the size of the impedance Z is not affected. By substituting the relations of inductance and capacitance, we obtain the below formula. Next, we need to evaluate the amplitude of electric circuit. The formula for expressing the impedances Z from the Ohm's law is given here. Now determine the amplitude of current Im, and we can derive this from the previous formula. And next, we need to evaluate the phase difference from the phasor diagram. Now the phase shift is expressed from the phasor diagram is usually in the form which is given below. And when we draw the phasor diagram and the phase difference, and the formula can be written like this, and the above formula can also be replaced by the given formula. So we must be careful in interpreting the results. In the first case, the numerator says that we consider the case when the voltage leads the current, similarly on the coil. In second case, the current leads the voltage. So we choose a suitable relationship either from the phasor diagram, where we can see the phase difference between the voltage and current, or we choose the one of the relations and interpret the result through the sign of the resulting value. Next, the numerical substitution. Substitute the given value in the formula, and thus we obtain the current amplitude Im equals 0.2 ampere. And next, calculate the phase difference by impedance, and its value is minus 2.4. Or it can be evaluated by using the voltage on individual components in the circuit. And here is the voltage on individual components of the circuit. Now we determine the size of the phase difference between the voltage and the current in the circuit from the phasor diagram. And you can see both methods gives the same result. The negative value says that the current leads the voltage, and the phase difference between the voltage and current is about minus 67 degree. Now let's see the answer. So in series RLC circuit, the amplitude of the current is approximately 0.2 ampere, and the phase difference between the voltage and the current is about minus 67 degree. The phase difference between the applied voltage and current can be negative as well as positive. Positive phase difference means the voltage is leading the current by the phase angle. When the phase difference is negative, the current leads the voltage by the phase angle. And here the sign of the phase difference is negative, so the current leads the voltage about 67 degree. Since the current leads the voltage, the circuit acts as a capacitor. And next, the circuit diagram.